grade 10s, and welcome to another video on exponents, and specifically where we are joining factorization into our exponents expressions. And you'll see later with the exponential equations, we also use factorization. So like I told my kids, this factorization is going to come back for you time and time again, all the way to matric. So please just learn to factorize. Okay, it will be in your favor. All right, and the main factorizations that we use with the exponents is HCF, the difference of two squares, or we can do the sum and difference of two cubes, but unlikely there, and then the trinomials. So please make sure that you understand these and it's solid in your mind and that you know how to do it. All right, so just before we continue, I just want to quickly show you two different things to note. Okay, note is that 2 to the power 2x can also be rewritten, am I right, to 2 to the power 2 raised further to the power x. Why is that? Because a power raised to a further power, we're going to multiply, which will give me this original expression. So remember, you can tweak things as long as you don't change the original expression. And I call this the switcheroo. We're going to swap these two around. 2 to the power x raised to the further power 2. Okay, why do we want to do that? Because we want to find bases and exponents that are the same. And just by giving you this hint going forward is how to do that so that we can factorize taking out a highest common factor of 2 to the power x. So just please note that 2 to the power 2x can be written as 2 to the power 2 raised further to the power x, which can also be a switcheroo. So in future, I'll be calling it this good old switcheroo. And you get 2 to the power x raised to the further power 2. Okay, the other one that I want you to note is 2 to the power x plus 4 can also be rewritten as 2 to the power x times 2 to the power 4. Because we were teaching you all this time up to now to change this, and to simplify this to that. So 2 to the power x times 2 to the power 4, we keep the same base and we add the exponents. Because they're not like terms where I can't squish them together, I can't add them. So I just do the sum there at the top, x plus 4. Okay, so this is what I call, we splitsies it. Okay, so you take that base and you apply it to both exponents there at the top. You splitsies it, and this one is the good old switcheroo. All right, so we're going to use that, especially when we want to factorize in our exponential expressions. All right. So I'm going to first show you the good old splitsies one. Not the good old, the splitsies one. Okay, so can you see that here is the term separator, which is the plus, which means there's a term on the left and there's a term on the right. So we want to try and find an HCF by doing some things to the left, doing some things to the right to find a highest common factor. And at the moment, I can sort of guess, can you see, I can guess that the highest common factor is going to be 3 to the power x, because there's also one at the bottom, and then they can actually divide out. Okay, so I'm going to show you how to splitsies them. So we're going to write 3 to the power x times 3 to the power 1. Big old plus sign dividing our two terms. 3 to the power x times 3 to the power 2. So when you take it back to this expression, I haven't changed anything. I'm just splitting them. Okay, splitsies. Over 7 times 3 to the power x. So now at the top, I cannot just go and divide out those 3 to the power x's because I've got two terms at the top. I want to make it one term. How do I do that? With factorization. So I'm going to take out a 3 to the power x in both terms. And then what is left? A 3 to the power 1 plus 3 to the power of 2. Oopsie. All over 7 times 3 to the power x. Now at the bottom, I don't have to do anything because it's already one term. Now I can go and divide out. And then I've got 3 squared, which is 3 times 3 is 9. And I left the 2 here. Sorry, you must be screaming, but ma'am, what about this 2? The 2 was there as well. So in here, we're going to have plus 2 times 3 to the power x. Sorry, so can you see it's 2? This pen. 2 times 3 to the power of 2. So now we've got 3 squared, which is 9. 9 times 2 is 18. 18 plus 3 is 21 over 7, which gives me 3. Okay, but I just want to show you, there's a quicker way instead of splitsies, making splitsies. There's a quicker way. So can you see at the top here, I'm just going to take out 3 to the power x. Why? Because I can see that they are common in both sides. But then what is left is you must make sure that this 3, is 3 to the power of 1 that's left. That exponent that's left is not just 1, that it's 3 to the power of 1. Plus, there's a 2 left, times 3 to the power of positive 2. Okay, over 7 times 3 to the power x, and then you divide out, and then you also get 3. You're more than welcome just to pop that into your calculator and get the answer as 3. There's no mark allocation for that. Okay, so if you can see it without splitsies, then you can do it. If you want to splitsies them, because it's easier, then please do so. All right, answer 3. I just always make sure that I've got the answers. Okay, so over here, now this one is a bit different because it's 2 to the power 2x. So this is the one where we're going to apply the old switcheroo. So it's 2 to the power 2 raised to a further power x times 2 to the power of 2. So can you see 2 to the power 2x becomes 2 to the power 2 raised to a further power x minus 2 to the power x over 2 to the power x times 2 to the power 2 minus 1. Now, if you were looking for an HCF, there is none. Okay, because this is 2 to the power of 2. Sorry, over there. It's not 2 to the power x. That's why I've taught you this little switcheroo trick. And then you're going to say 3, sorry, not 3. It's going to be 2 to the power x all raised to the power 2 times 2 squared is 4 minus 2 to the power x over 2 to the power x times 4 minus 1. Now this looks too hectic, too horrible to comprehend. So what we're going to do is we are going to make it simpler for us. So please, because this is, I don't know what, I can't even see what factorization I must do here. So can you see the 2 to the power x that is everywhere? We're going to make that another number so that it's just a plain old base number. So I'm going to say, let 2 to the power x be equal to k. Now, k, it could be anything. Could be m, could be l, could be s, could be r. K is just something that we use a lot. We use the k because we talk about the k method later on. So we're going to just use k. You can use anything. All right, just please make note of that. Make note of that. So we're just going to simplify it for ourselves to reduce our logical thinking, or the expression, just to make it simpler for us. Okay, and then we're going to, at the end, whatever answer we get, we're going to replace the k, because we worked it out in terms of k, back to that k is equal to 2 to the power x. Okay, so we've got k squared times 4 minus k over k times 4 minus 1. All right, so let me just rewrite it in terms of how we know it. 4k squared minus k over 4k minus 1. And then you're going to say, okay, now I can sort of see what factorization should be done. I can take out a highest common factor of k at the top. And what is left? 4k minus 1. Oh, my word, look at that, 4k minus 1. And you can bundle it together. Why? Because it's alone at the bottom. Then they cancel out, and your answer is k. And lots of you stop there and say, yay, my answer is k. But you must go back, because your answer is actually not in fact k, it's 2 to the power x. Okay, so just remember to go and replace now. That k is not k, but k is equal to 2 to the power x. Thus, your answer is 2 to the power x. Okay, and I know you shouldn't have equals equals. All right. You can say but k is 2 to the power x, thus it's 2 to the power x. All right. Okay, let's quickly look at the next one. I can already see 3 to the power x over here, 3 to the power x over there, 3 to the power x. So without splitting it, I don't like it because it overcomplicates my things. So I'm going to take out a 3 to the power x at the top, and what is left, as long as you remember the base goes with that exponent. There's a 3 to the power 1 left plus a 3 to the power 2. All over 8 times 3 to the power x times 3 to the power 1. So why do I split these there? Because I want to separate them so that I can delete those 3 to the power x's. So now I can delete that, and then I've got 3 plus 9, which is 12, over 8 times 3, which is 24, and my answer is a half. All right, so over here, oh, I think I wrote all the different answers at the different sums. I just want to make sure. 3 to the power x, I took out 3 to the power 1 plus 3 to the power 2 over 8 times 3 to the power 1. Delete the 3 to the power x's. Why do I delete it? Because I've got one term. And then you've got 12 over 24, which is a half. Okay. All right, let's look at this one. I can already see there's a 3 to the power x at the top. I don't have to factorize. It's already one term. And there's a 3 to the power x at the bottom and a 3 to the power x over there. So I just need to break them up. 2 times 3 to the power x. All over, if I take out 3 to the power x, what is left? 3 to the power 2. And if I took out, whatever I took out, remember, if you took out that exact thing, that divided by that always leaves you with 1. Okay, so please don't forget that minus 1. Some of you just drop it or just leave it alone. Okay, and then the 3 to the power x, or not leave it alone, you just, it just disappears for you. Okay, so delete the 3 to the power x, then I'm left with 2 over 3 squared, which is 9. 9 minus 1 is 8, which is then a quarter. Okay, nice and easy one. Example 5. Okay, so can you see there's a 3 to the power x? Why I chose these are specific because every time something small changes and then I sit with a minus 1, I just chose them specifically because they are different to the ones from each other. Okay, so at the top, if you look at your two terms, can you see your two terms over here? In both terms, there's a 3 to the power x that I can take out. Now, what is left? A 2 times 1, which is just 2, plus 3 to the power negative 2, all over at the bottom as well. I'm going to take out a 3 to the power x. What is left? 5 times 3 to the power 1 minus 7 times, not just negative 1, 3 to the power negative 1. Okay, now we delete those two. Lacquer, they fall away. And then that you are welcome just to go pop into your calculator and you should get 1 over 6. If it's a little bit hard, you can do it in stages. Remember that your calculator can do a negative exponent. So you can go and pop in 2 plus 3 to the power negative 2, which will be 2 plus 9, and then your calculator will work out the rest. Okay, but your answer should be 1 over 6. I'm not going to spend too much time on the calculator work. All right, the old switcheroo. So if you see a number in front or coefficient in front of your variable in the exponent, then we know we're going to do the old switcheroo. Okay, so that 2 to the power 2 raised to the power x. I'm sort of going to now immediately as I'm doing this, I'm going to swap them around and say, and the more you practice this, the more it will just happen naturally. So 2 to the power x all raised to the power 2 minus 3 times the switcheroo 2 to the power x all raised to the power of 2 all over 3k squared times a quarter. As you can see at the top, I can take out a k squared in this term and a k squared in that term. So I'm going to do an HCF of k squared. What is left? 1 minus, so remember if you took out exactly that, there has to be a 1 left, minus 3 times a quarter over, if you take out a k squared there, just going to push them together like this, or just rewrite it like that so that we can see the k squared nicely to be divided out. And then again, once you pop this into your calculator, 1 minus 3/4 divided by 3/4, it should give you a third. Okay, so I'm not going to go too much into the calculation. You can just use your calculator to pop it in there. All right, so over here, there's 2 terms at the top, 2 terms at the bottom. I'll have to do the switcheroo. Why? Because there's a 2 in front of my variable in the exponent. Okay, so at the top, I'm just going to do the old switcheroo. 3 to the power x all raised to the power 2 times 3 to the power 1 plus 3 to the power x raised further to the power of 2. Okay, so please make sure that you can do that somewhere immediately, that it's something you get the hang of immediately. Over 3 to the power x times 3 to the power x times 3 to the power 1 minus 3 to the power x all raised to the power 2. Okay, again, this looks hectic. I'm going to replace and say let 3 to the power x equal to k. Oh, shucks. All right, yeah, sorry, the k is divided out, so I didn't have to go and replace it. Just wanted to make sure over there. Okay, so then I'm left with k squared times 3. So I can rewrite that as 3k squared plus k squared all over k squared, not k squared, sorry, 3, let me just quickly make sure, yes, that was 3 to the power k squared. All right, so at the bottom, 3 to the power x is just k, so it's k times 3 minus k squared. All right, so let me just go and simplify that a bit. So I've got 3k squared plus k squared over k times k is k squared. Keep your same base and add those exponents. Times 3 is 3k squared minus k squared. So I'm going to take out a k squared at the top, and what is left is 3 plus 1. Can you see that? If I take out k squared as my HCF, there's a 3, and if I took out exactly what was there, there's a 1. And at the bottom, I can take out k squared, which is 3 minus 1. That's left. So 3 plus 1 is 4 over 3 minus 1, which is, 2, which gives me the answer 2. All right, then let's look at the last 2 sums. That is a little bit more tricky, but don't stress, we're going to do this. All right, so if you see 10, we can say, all right, remember our prime factors. So we're going to change that 10 into the prime factors, which is 5 times 2. So it's going to be 5 times 2, all raised to the power x minus 10, which is also 5 times 2, all raised to the power x minus 1. Okay, and the bottom, there's actually nothing to do. We can factorize so long. We can see that we're going to take out 5 to the power x times 2 to the power x. And then what is left? 5 to the power negative 2 times 2 to the power negative 2. Okay, I hope you can see that so far. And at the top, we're also going to pull out a 5 to the power x, 2 to the power x. Okay, so At the top, everything inside the bracket is to the power of x. So it's going to be 5 to the power x times 2 to the power x minus 5 to the power x minus 1 times 2 to the power x minus 1. All over the top bottom that I've already factorized. Okay, so lots of writing. So can you see if I splitsies them, yeah, I can also take out 5 to the power x, 2 to the power x. So if it's best, let's rather rewrite. It's going to take a long time to write, but let's do it. 2 to the power x minus 5 to the power x times 5 to the power negative 1 times 2 to the power x times, 2 to the power negative 1. Okay, so I just splitsies it all over 5 to the power x times 2 to the power x that I've already factorized. Okay, now at the top, I'm going to take out from, let's highlight it with a lighter color. From this term, can you see I can take out a 5 to the power x times 2 to the power x. And then if I had to highlight the other part, the other term, oopsie, that's not the highlighter. If I highlight this, I've done it on yellow as well. It's okay. Then you'll also have a I'm going to take out 5 to the power x times 2 to the power x. So what is left? If you've taken out exactly what is there, then there's a 1 left. Minus. Now the 5 to the power x and the 2 to the power x is out because we've taken it out as a highest common factor. So what is left? 5 to the power negative 1 times 2 to the power negative 1. All over 5 to the power x times 2 to the power x, and what was left here, 5 to the power negative 2 times 2 to the power negative 2. So yippee-kadoodah, that can delete out, and then if you pop this correctly into your calculator, you should get 90. All right, so remember your calculator can work with negative exponents. So just what I would suggest is 1 minus, and then remember to put this into brackets. Then press equal, then divide by bracket 5 to the power negative 2 times 2 to the power negative 2. So just guide your calculator as to know what you want to combine, or what, to follow BEDMAS as well. All right. Then the last example that I'm going to do today, which is also quite tricky. So again, I'm going to do the old switcheroo. I'm going to say 8 to the power x raised to the further power 2 minus 2 times 8 to the power x minus 8 all over switcheroo 8 to the power x all raised to the power 2 plus 2a to the power x. Oh my word, it's too much to comprehend. Let me pull in my k. Well, that color is too close. Okay, so we're going to say let a to the power x equal to k. So we're going to change. Wherever we see a to the power x, we're going to change it and substitute a k. This pen, minus 2k minus 8 all over k squared plus 2k. Oh my word, look at that. When I didn't substitute the k, I didn't know what was going on at the top there. But when I did it, can you see shouting at me that this is a trinomial and this is an HCF? Okay, so please use this method. It really helps. So we're going to factorize the top. We're going to take out a highest common factor of k there. Let's just do that. That's quite quick and easy. The k splits. They are different. The first one is a minus. And 4 times 2 gives you 8. And minus 4 plus 2 does give you the negative 2k over there. Oh, wonderful. So what is left? If I can divide that out, and then I'm left with k minus 4 over k. But But remember that I substituted k with a to the power x. So your answer should be a to the power x minus 4 over a to the power of x, like it states there. All right. Oh, I hope it helped. And just please be brave with the exponents. Just know your basics. And then the two parts that I showed on top is very important to note. The switcheroo and the splitsies, if you need the splitsies. Okay. Oh, thank you, grade 10s. Thank you for watching, and I hope you have a wonderful day further, and see you next time. Thanks, bye.